Okay, example 9, determine the vertical and slant asymptotes of f of x equals x cubed plus 1 over x squared minus 4. Sketch its graph. It does specifically ask us for slant asymptotes, so I know for a fact it has them. But just looking at the structure of the equation, just in case the problem says sketch the graph, just to know the reason it has a slant asymptote is the highest power on top is exactly one more than the highest power on the bottom. As far as vertical asymptotes are concerned, what's important to me there is the denominator. So x squared minus 4, if I set that equal to 0, x squared minus 4 factors to x plus 2 times x minus 2, which gives me x equals negative 2 or x equals positive 2 as possible vertical asymptotes. We do have to verify that neither one of these values makes the numerator also equal to 0, or else we'd have to throw them out. Negative 2 cubed is negative 8 plus 1 is negative 7, so that's fine. If I try x equals 2 up top, 2 cubed 8 plus 1 equals 9, also not 0. So both of these are vertical asymptotes. As far as the slant asymptote is concerned, I'm going to do that up here. To do slant asymptotes, I simply divide the top by the bottom, so x squared minus 4 goes outside. X cubed plus 0x squared plus 0x plus 1 goes on the inside. And if I divide first by first, x cubed divided by x squared is x. X times x squared is x cubed. X times minus 4 is minus 4x, lining up like terms. Change both signs. That cancels. 0 is 0. 0 plus 4 is 4. As long as this power is less than that power, I can't divide anymore, so this would represent the numerator of my remainder term. The remainder term doesn't matter, so x is the quotient of these two things, with some remainder, again, that doesn't matter. So the slant asymptote is simply going to be y equals x. Okay. All that means is as we go towards positive infinity and goes towards negative infinity, the graph should be getting very, very close to the line y equals x. Next thing we do is once we've established the asymptotes, we can't have both a slant asymptote and a horizontal asymptote. So the fact that it has vertical asymptotes and slant asymptotes, that's all the asymptotes there can be to this. Now it's just a matter of finding some points. So what I want to do for picking points, one other thing I should really find would be intercepts. If we look at the x-intercepts, if I set the numerator equal to 0, that's x cubed plus 1. That gets me x plus 1 times x squared minus x plus 1 equals 0. That gets me x equals negative 1 for this one. If I did the quadratic formula on that, I get imaginary answers. So negative 1 comma 0 is the x-intercept. And then if I go to do the y-intercept, all I got to do is set x equal to 0. So x is 0. 0 plus 1 is 1. 0 minus 4 is negative 4. So 0 comma negative 0.25. Two rather easy points to find. If you find that either one of those points is difficult to find, hopefully you never find the y-intercept difficult. But if the x-intercept is difficult and they haven't specifically asked for the x-intercept, you don't really have to find that point. But just, again, usually it's not terribly difficult to find, so we usually find it. All that's left after that is just to pick values, and I would pick numbers near negative 2, going to the left, going to the right of negative 2, starting exactly 0.5 to the left, and then 1 to the left and 2 to the left. If I go 0.5 to the right, it's negative 1.5. 1 to the right is negative 1, 2 to the right is 0, so those have both been picked already. If I'm going from 2, 1 to the right of 2 is 1.5, or 0.5 to the left of 2 is 1.5. 1 to the left is 1, 0 we've already picked. Going the other direction, 2.5, 3, and 4. And that may be perfectly good. Anytime I'm trying to do these problems, if I'm trying to determine whether or not I've got enough points, once I look at all the points graphed, if I can see what the graph's supposed to look like and connect the dots with confidence, that means I've got enough points. If I can't, that means I need to get more values. So what I would do here, first of all, I'm going to clear my table, get rid of anything that's already in there. I'm going to clear out my stuff here, enter the exact function I'm trying to graph, which is x cubed plus 1 divided by x squared minus 4. Be careful with all these rational functions that we're encasing the numerator and denominator in parentheses. I come over to my table and enter all of my numbers. I've already got -1 and 0 evaluated. If I'm not sure, I can always put those numbers in to verify that I got the right results, which I do. Continuing on, got -2.5, -3, -4, -1.5, +1.5, 1, 2.5, 3, and 4. And that gets me all these results, so if I go ahead and record those, -6.5, -5.2, +5 point, oh, hang on. That's supposed to be a -4 there. -5.25. And then we got 1.36, -2.5, -0.67, 7.39, 5.6, and 5.42. Okay, looking at the results, the answers are as small as -6.5, as big as 7.39, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up and down gives me enough space, of course, to fit those on there. So a 1-to-1 scale is probably going to be sufficient for this. I never want to plot my asymptotes or my anything really until I've decided what kind of scale I'm going to use. So I do want to kind of get a lot of information before I start putting stuff to graph. X equals -2. X equals +2 are my vertical asymptotes. And my slant asymptote is y equals x. That's just a linear equation. Slope of 1, y-intercept of 0. So if I just kind of go left 1 and down 1 each time, connect the dots with a nice straight line like so. I know the graph itself is going to be bordered, or is going to be kind of contained by these asymptotes. What you need to remember about slant and horizontal asymptotes is they can be breached near 0. Typically when you see this picture, you're going to have part of the graph either here or here. Usually doesn't breach the horizontal or the slant asymptote out here. If it's going to be crossed, it's going to be probably within the middle of these two, right around 0. And out here is probably going to be either here or there. So again, it's just a matter of plotting what you've got, seeing where things are to kind of get an idea of where everything belongs. -1, 0 goes right there. 0, -0.25 would be just below. And you can see that it's continuous from here to here. So I can see that the slant asymptote is going to get crossed somewhere in that area. -2.5, -6.5 would be right about here. -3, -5.2 is about here. -4, -5.25. Those are almost horizontally positioned from one another, so we might need to get more information about that area down there. -1.5, 1.36, just a little bit below halfway. 1.5, -2.5 would be here. -1, -0.67 is right there. And then we got 2.5, 1, 2, 3, 4, 5, 6, 7.39. 3, 1, 2, 3, 4, 5.6. 4, 5.42. And once again, maybe that's enough information, but I probably want to get a few more points over here. So looking at the three sections, this looks like it's down here, this looks like it's up here, and this looks like it does breach. But again, I got enough information here if I just connect what I have. That's what that looks like. It looks pretty good to me as far as it's going to continue going straight up the asymptote and straight down the asymptote there. So that's sufficient for that part of it. I don't have enough information for these two, so I want to get more points over there. Two things I want. Number one, this looks horizontal. I know the graph's not going to go straight across. My guess is it kind of goes up a little higher between those. So maybe picking this x value here, -1, 2, 3.5. And then to kind of get a feel for how close the asymptote it gets, I'm going to probably pick way out here at -8. Just to kind of see how close the asymptote it gets as we go off that direction. And same deal here. Again, maybe it just kind of cuts down like that, but at some point it's got to go up. So I kind of want to get more information there. So if I just kind of pick this area, 1, 2, 3.5, and then all the way out here at +8. Also to get a better view of what's going on. Nothing magical about those numbers. They're just going to give me a little bit more information about what I'm looking at. Delete some of these out so I have room. So -3.5, -8, +3.5, +8. and that gets me values of negative 5.08, negative 8.52, positive 5.32, positive 8.55. We're still not outside the scope of the graph. This goes down as far as negative 10, as high as positive 10, so everything still fits fine. Negative 3.5, negative 5.08, which is a little bit lower than negative 5, so it actually does hit a higher point there. Negative 8, 1, 2, 3, 4, 5, 6, 7, 8.52, just a little bit below halfway there. So it kind of shows me that it stays kind of close to the asymptote there, and then it kind of just comes around like so. So I know that part should kind of do like that. And then over here, 3.5, 1, 2, 3, 4, 5.32. This was 5.42, so it's just a smidge below that. Then 8.55 off of 8, 1, 2, 3, 4, 5, 6, 7, 8.55 would be about there. Again, it gives me a clearer view of what's going on. It's going to go down, around, and over like so. And as always, we can check once we get everything graphed. Obviously, this isn't part of the graph. I just was marking those for the visual of where we need to pick x's. But if I were to take this and take my calculator out, set my window the same window, so I'm going from negative 8 to positive 8 on the x-axis, and negative 10 to positive 10 on the y-axis. Keep in mind that this is more vertically positioned, this is more horizontally positioned, so the graph might be somewhat distorted. We should see a section down here, a section looks like that, a section up there. Along with, if I were to put y equals x, which is my slant asymptote equation in, you can't put in vertical asymptote equations, but you can put in slant and horizontal asymptotes, y equals number or y equals some function of x. That would allow me to see that graph. There is my graph that we made. It has our three little sections there. The slant asymptote, you can see, is positioned correctly based on that. And again, a little bit of distortion there. It looks like kind of scrunched up in here compared to that, but again, that's just because different orientations of things. But the graph you see on your calculator along with your graph you see on your paper should look pretty similar to each other. If they don't, you probably didn't pick enough x values. Pick more x values to get more points to get a better view of what your graph should look like.